In this lesson, you will learn how to use the trig ratios to solve triangles. Recall that the sine ratio is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These trig ratios work for right triangles. We can find missing angles of right triangles by using the inverses of those ratios. A saying that you can use to remember the trig ratios is some old hippie for sine, some old hippie, caught another hippie, tripping on, and you pick your A word. It can be acid, air, apples, any word that you feel is appropriate here. So tripping on A for the adjacent. So let's first start with our example number 1. We're going to find the missing side length, round to the nearest tenth. We are going to use 2 different color highlighters, so if you'd like to pause the video and get out some highlighters at this time. Using triangle STU, we're going to find the length of SU. So SU is our missing piece. So here is side SU. We have the angle measure of 54 degrees, and we also have a side measure of 87. So we're only going to label the parts of the triangle that we need to find or we already know. So our 54 degrees is our angle. That is our theta. From that theta angle, we will label the sides that either we know or we need to find. So we know this side being opposite of the angle, and we need to find this side that is adjacent to the angle. You could label the hypotenuse. The thing is, you don't know the hypotenuse and you don't need to know the hypotenuse. So labeling that will just maybe get confusing on what ratio to use. So looking at our trig ratios, we want to look for opposite and adjacent. Some old hippie, we would need to have hypotenuse in order to use sine. Caught another hippie, again, we would need to know the hypotenuse or need to find the hypotenuse in order to use cosine. Tripping on A for adjacent, here we can use tangent because opposite and adjacent are the pieces that we need to find or we have in our triangle. So we're going to use tangent of theta, which is opposite over adjacent. So let's plug in our pieces of the triangle. So we're going to do tangent of our theta angle is 54 degrees equals opposite is the piece we know, so 87 divided by adjacent, that's what we don't know, so use a variable. You can use X, you can leave it as an A, you can come up with your favorite letter, whatever you want to solve for. So notice here, the pieces that we need to find are unknown, and the pieces that we know, the 87 and the 54 degrees, we pick the tangent based on those 3 things. What we know and what we need to find is how we knew to pick tangent. So let's solve this. I'm just going to rewrite it since that one's all highlighted. So we have tangent of 54 equals 87 divided by x. We need to get x solved by itself. Notice it's over here currently dividing into 87. So let's multiply it on both sides to undo that division. We end up getting x tangent of 54 equals 87. It didn't get x by itself, but we can take another step to do that. Divide by tangent of 54. When you have x by itself, that's the exact thing that you punch in the calculator. Don't punch anything into the calculator until x is already by itself, or whatever side you're solving for is by itself. So this 87 divided by tangent of 54, we go to our calculator. Before starting using your calculator, reset the calculator and check the mode. So second memory, 712, second plus sign, 7, 1, 2 is how you do a reset. And then we go to our mode key. After doing a reset, it automatically resets everything to the left-hand side, seeing that radians is selected and we need degrees. These angle measures are in degrees, so that's why we select that in our mode. So when you have selected that, you can arrow down to make sure it really did select, and then do second quit to get out of that menu. We will not need to reset that every problem, because once it's set, it does stay in that mode. If you do a calculator reset, you will need to change the mode. So we are going to type in 87 divided by tangent of 54. You can set it up this way just with the division, or you can do alpha y equals and choose that first option and set it up as a fraction. It will work either way. So notice our answer here, 63.2. If we're rounding the nearest tenths, look behind. Don't continue looking behind. Just look one place behind the tenths place. That 0 will make the 2 stay. It has to be a 5 or greater to make it round up. So we have that our x equals 63.2. So really that's for side SU. So really if you want to put SU instead of S. Let's go to our next example. Here we have side LM is what we're trying to find. So LM is here on our triangle. We know some provided informations, 42 and 19. So we're going to label either what we need to find or what we already know. We don't need to label the other parts of the triangle. So when we label this triangle, our theta angle is 19 degrees. The piece we need to find is opposite of that theta angle. If you're standing in this corner of the triangle and you walk to the opposite side, you would touch this side. The 42 is the hypotenuse. The side that's opposite the 90 degrees is always the hypotenuse. Some people draw an arrow to help them see. From the 90 degrees, straight across opposite that is the hypotenuse. So we have opposite and the hypotenuse. Let's go and look at our ratios to see. Some old hippie, well there it is. Opposite hypotenuse, we'll use sine. So sine of theta equals opposite over hypotenuse. Let's plug in our numbers. So sine of our 19 degrees, which is our theta angle, is opposite. We don't know that, so let's use a variable. You can use x or m or q or whatever letter you want to use. I probably wouldn't use O. Of course, that could be confused with a number 0. And then our hypotenuse is 42. So notice, here's our missing piece, the piece we need to find. Here's our 2 pieces that we were given to begin with. And because of those 3 things, what we needed to find and what we were given, that's how we knew to pick sine as our ratio to use. So let's solve this. I'm just going to rewrite it. If you're trying to solve for x, they have divided by x, so the opposite of that would be multiplying. No, they divided by 42, so the opposite is multiplying. They did not divide by x. So multiply by 42 on both sides. So notice once you do that, your x is by itself. Once x is by itself, you're ready to go to the calculator. So when we have our calculator, we've already changed it to degree mode. You can go back and check and make sure if you want to feel comfortable, but it does stay in that mode. So 42 times sine of 19, and that gives us 13.67. When we're rounding there's tenths. If this is the tenths place, look behind that, and it makes it round up. This number is 5 or more, so to make that tenths place round up. So 13.7 for our x, or really here we were asked to find LM. Either way is fine. You can leave it as an x or write it as the side that you are finding. So for example 3, this time we're going to find the sine length of xy. So here is xy. We were given our angle measurement of 47 degrees and a side measurement of 26. So let's label the pieces that we know and that we need to find. We know this angle measure, so that's our theta angle. The side that's opposite of the theta we don't know and we don't need to know, so it's not real helpful to label that. It might confuse you in your work. The side here that's adjacent is given to us, as well as the hypotenuse is what we need to find. Remember, the hypotenuse is opposite the 90-degree angle. So let's decide on our ratio based on adjacent and hypotenuse. So some old hippie, we need opposite to use sine, and we don't have that. Caught another hippie, this is the ratio we would use. We have our adjacent and we need to find our hypotenuse, so that tells us to use cosine. So cosine of theta equals caught another, so adjacent hippie is hypotenuse. Cosine is caught another hippie, so cosine is adjacent over hypotenuse. And let's plug in our numbers. So cosine of 47 equals, the adjacent side is 26. Hypotenuse is the piece we need to find. So again, notice here is the piece we're finding. Here are the pieces that we know. And because of those three things, because of what we know and what we needed to find, that's how we knew to choose cosine. Because we had adjacent and hypotenuse. Either we knew one piece and needed to find the other. That's what made us pick cosine. So let's set up and solve this equation. Notice again, they've divided by x. So we're going to multiply by x. This doesn't actually get x by itself. Puts x with this cosine of 47, so we have another step to actually solve. Divide now by cosine of 47, and that does now get x by itself. So this is when we type in the calculator, is when x is by itself. We have 26 divided by cosine of 47. Rounding that to the nearest tenths, here's the tenths place. Look behind that. This 2 will not make this round up. The 2 would have to be a 5 or more in order to make that round up. So we have x equals 38.1 because it will not round up. So let's see how we can use these trig ratios to find missing angles. This time we're going to round to the nearest whole degree when we're solving for angles. So let's find what we need to solve for. So it's asking us to find the measure of angle A. So here's our measure, or here is our angle A. And let's find what we have given to us. We have given to us this 5 and this 10. So angle A, because it's what we need to solve for, that's our theta angle. The 5 from that theta angle is opposite, and the 10, because it is opposite of the 90 degrees, that is our hypotenuse. So based on opposite and hypotenuse, we've got to decide which ratio to use. The ratios do work the same as sine, cosine, and tangent, but this time we're going to set it up as an inverse because we're solving for the angle. So some old hippie, because we have opposite hypotenuse, that is sine for some old hippie. So our theta angle is going to equal inverse sine, so sine to the -1 of opposite over hypotenuse. So let's plug in our numbers. Our angle A, the angle we're trying to solve for, is going to be inverse sine of opposite, or our opposite side is 5, over the hypotenuse, which is 10. So again, once you have this set up, you're ready to go straight to the calculator because what we're trying to solve for is already by itself. So let's go to the calculator. Inverse sine, you'll have to press second, because if you'll notice, sine is in blue, just above the word sine is inverse sine. So press second sine, then do 5/10. Again, this will work as just division, or if you prefer the alpha y equals to put in the fraction. When we do inverse sine of 5/10, we get 30, and that is an angle measure in degrees, so 30 degrees. Make sure you include the correct units. Let's look at example 5. This time we're going to be finding the measure of angle J. Here is our angle J. We also are given some information. We have this 46 and 93. So let's label the parts of the triangle either that we know or that we need to find. So angle J is going to be our theta angle. From that theta angle, label the pieces that we're given. The 46 is opposite. The 93 is adjacent. The side that we don't know or don't need to find is the hypotenuse, but I don't recommend labeling that. It just makes it more confusing to find which ratio you need. So some old hippie, old, which is the opposite, we have, but hippie we don't have and we don't need to find. Caught another hippie. Another for adjacent hippie, again, we don't have the hypotenuse, we don't need to find the hypotenuse, so we will not use sine or cosine. Tangent is tripping on acid, so we will use tangent. Remember, when you're solving for an angle, you actually use inverse of the function. So inverse tangent is opposite over adjacent. So our angle J that we're trying to solve for is inverse tangent, and plug in your opposite and adjacent, 46 over 93. Once you have what you need to solve for by itself, so in these inverse functions, they will already be by themselves, you're ready to go straight to the calculator. So inverse tangent, so second tangent of 46 over 93. That gives us rounded to the nearest whole number, so if we're rounding to the nearest whole number, look one place behind, so you'll look at the tenths place. That 3 will not make this round up. That would have to be a 5 or better to make it round up. So angle J is going to be 26 degrees. Let's look at our final example, number 6. We're going to find the measure of angle Y. So here's our angle Y. We're given this as 16 yards and 20 yards, so let's label those pieces of the triangle. Angle Y is our theta angle. From that angle, the opposite side we don't know and we don't need to know. The adjacent side is the 16 yards, and then the hypotenuse is the 20 yards. So from the 90 degrees angle, it's a terrible arrow. There we go. From the 90 degree angle, look across from that, opposite that 90 degrees is always going to be your hypotenuse. So let's decide on our ratio. Some old hippie, we'd have to have opposite, caught another hippie, so another hippie, that tells me to use cosine. So angle theta, because we're solving for an angle, we'll use the inverse, is adjacent over hypotenuse. Caught another hippie is cosine. So let's set up with our values here. So angle Y is what we're trying to solve for, equals inverse cosine of adjacent. So the adjacent is 16 over 20 for the hypotenuse. And now we're ready to punch that in the calculator. So we're going to go second inverse cosine of 16 over 20. Rounding that to the nearest whole number, look behind, that 8 rounds up and makes this 37 degrees. When rounding, you do not continue looking back further and further and further. If you're rounding this whole number, you only look one place behind, and that 8 is what's causing this to move round up. So angle Y is 37 degrees.